So, Zubair, did you got? Did you got a chance to go through the videos? Any questions on previous sessions?
Confusions are still there, sir. But let me actually, I'll just ask you after when I get
Sure,
call.
sure.
Yes.
No. Okay. So today we are going to talk about controller architecture. So controller means nothing but our node, right? It might be FAS or AFF or ASA. So we discussed that cluster will have multiple controllers. Cluster is nothing but a group of controllers or a group of HA pairs, right? So that is fine. Now we understand what is cluster and how, what are the specifications like limitations, how many nodes we can add, all those things we discussed. Like can we mix different models or not? All these things we discussed. Now we'll discuss about the components inside controller, like what are the components inside the controller, how they will work, and like we will discuss all the things. Okay, so let's assume that this is our controller. Okay, this is our, let me draw it a little down. Yeah, this is our controller. Okay, and first we'll talk about the ports on top of the controller. What are the different types of ports available? Okay, after that we'll talk about the components inside the controller. So generally there are three important ports on top of the controller. Initially three ports. Okay, the first one is, okay, we'll call it as console or serial port. Okay, console or serial port. What is the uh, purpose of this port? What is the purpose of this? What is the purpose of this port? Generally, whenever you got a controller, okay, so how you can access it? First, you need to do initial configurations, right? Like you need to assign the IP address and all the things. Okay, normally if you configure the IP address, then you'll be able to connect to the controller with the help of IP address and all. But you have not configured anything. This is a controller which delivered to you from NetApp very recently. Then how you will be able to access the controller and you will be able to configure the controller. So what we need to do, we have a port called console port. Okay, we have a port called console port. So we need to connect the cable to the console port and other end of the same cable to your laptop, so that you will get access to the controller through this uh, console or serial port, and you can do the initial configurations. Okay, basically you, in order to access the controller by connecting directly, okay, you can connect to the controller directly with the help of this console or serial port. Generally, we don't use the console or serial port frequently. This is only for initial configuration purpose. We'll do that. After that, we don't need to connect to the console port. Okay, so this is for initial configuration. Okay, mostly console or serial port is for initial configuration only. So next thing is service processor, or let's talk about E0M. E0M. Okay, E0M. So E0M is a management port. Okay, we'll call it as a management port. So during the initial configurations which will be performing through console, we will configure IP address. Okay, IP address to this management port. Once we configure the IP address to E0M, we don't need to connect to the controller through via console. Okay, we can connect to the controller with the help of IP address. From anywhere, from any location or anywhere, you can connect to the controller and you can do rest of the configurations or you can manage it. Okay. Generally, 90% of the work, not 90, 95% of the work, whatever the things we'll do day to day basis, everything will do it through management port only and management IP address only. Okay. So this is for daily work normally. Okay. So next thing is service processor, or some in some controllers we'll call it as a BMC. Okay. The full form is service processor, or BMC means I forgot that actually something. Okay. The purpose is same. So service processor is, or BMC is another port which will be on top of the controller. Okay. And as I told you, during the initial configuration, we will configure another IP address to service processor. Okay, once we configure the IP address, by using that IP address, we can connect to the service processor or BMC, and in the back end, this service processor will be having a connection to our console. Okay, the service processor will be having a connection, direct connection to the console port. Okay, so for what you can do, you, in order to connect to the console, you don't need to do a cabling between your laptop or and your storage controller console port. Okay, if there is a IP configured for your service processor or BMC, what you can do, you can connect to your service processor or BMC with the help of IP address, and from there, by running a small command, you can connect to the console. Okay, but initially, why we have connected the console directly? Because that time we don't have any IP address configured with service processor. That is the reason for initial configuration we must connect to the console or serial port. But after that, after configuring the management port, and after configuring the service processor, you don't need to connect to the console anymore. If there is a purpose to console connect to the console, you can do it through service processor. You don't need to go to the controller location, and you don't need to connect via cable. Okay, just log into the service processor with the help of this IP address. From there, run a small command and connect to the console port. Okay, so what is the purpose of the this service processor? The main purpose of the service processor is remote console connectivity. That is the main purpose. Apart from that, service processor has other purposes as well, but we'll talk about them in advanced section. Okay, not now. Okay, that is the main functionality of the service processor or BMC, remote console connectivity. So why we require these many ports? Only for management. Okay, all these ports are the purpose of this. All these three ports is connecting to the controller, right? Then why we need that? Okay, okay, fine. Console port is, I know, initial configuration, but when we have EasyRAM, why we need a service processor again? Because whenever we are doing some kind of maintenance activity on top of the controller, maintenance activity in the sense of, for example, I want to perform a data on type upgrade, or I want to replace a faulty hardware on my controller. In order to do these kind of activities, either we need to reboot the controller or we need to shut down the controller, right? So when you reboot or when you shut down the controller, along with controller, our EasyRAM port also will goes down. Okay, when EasyRAM port went down, you'll be not able to connect to the controller with the help with the IP address of the management port, IP address which we configured on top of the management port, right? So if we lost the access to controller, we'll be not able to see what is happening in the background, right? Okay. What if our controller is not booting up? What if our controller is not coming up? We can't do anything, right? Okay. Again, what you need to do in order to do an investigation, you have to connect to the console, right? But for example, I'm in India. I'm from offshore support. I'm supporting a client in USA. Okay, so my storage controller and everything is they are in USA, and I'm supporting from India. Will they take me to US only to do this kind of activity? No, right? So that is the reason they have designed. Okay, they have designed this service processor. So even though your controller is shut down or your controller is rebooting, the service processor will be always up and running. When your controller is connected to power connection, your service processor will be always up and running, so that even if your controller is down also, you can connect to the service processor with the help of the IP address we configured, and from there we can connect to the console. We don't need to connect to the console directly with wire and all. Okay, so you can connect to the console with the help of service processor also, and you can troubleshoot it, like why my controller is not booting up. Okay, these kind of things we can do. So mostly whenever we are doing maintenance activities, we will not connect to our controller via EasyRM management port, because as I told you, management port will goes down along with controller. So mostly we'll connect to the controller by to the console of the controller via service processor. Okay. Any questions, guys? These are very, very important. These three ports, sir. If you don't understand, ask me again. I'll try to explain it in a different way. Like if you don't understand. Subir.
Is actually this management IP port is only used to do day-to-day activities as such, but only if the
Ex-
controller goes down completely, then this service processor comes into picture, right?
exactly, exactly. Normally 95% of the time we'll connect to the EasyRAM port only, EasyRAM port IP address only. But if you whenever you want to do some maintenance activity, then only we'll connect to the controller console through service processor. I'll show you. I can show you all these things in our lab. Yeah, how to connect to the. Normally, we'll use EasyRAM only most of the times to connect to the lab, but I'll show you the service processor also, how to connect to the controller through service processor as well and
Sure.
console as well. Okay. Yeah. Okay. Next thing is, apart from these, we do have few ports. Yeah. Apart from these two, yeah, we do have few ports. For the just the diagram sake, I'm drawing only 3 or 4 ports, but generally the number of ports which I'm drawing right now, they'll be depends on your controller model. I mean, the service processor and all, these are 3 ports only, but whatever the other ports I'm drawing now. Okay, these are network ports. Okay, NIC, network interface cards. We have already discussed about these things, right? When we are talking about a NAS, NIC, network interface cards. Okay, network interface cards. So what is the purpose of these NICs? NAS connectivity. So through these NIC ports only, uh, our clients will access the storage from this controller. Okay. So these NIC ports will be connected to LAN, and our servers and all connected to the same LAN. So whenever they want to access the storage, they'll be able to access the storage from this controller via these NIC ports only. Okay. These are for NAS connectivity. So along with these ports, as I told you, for diagram sake, I just draw only 3 ports, but the number of NAS ports and NIC ports depends on the your controller model. If your controller is a like 8000 series or 8200 series or 9000 series, you'll be having like 12 or something. I mean, again, depends on the hardware model. Each and every hardware model, it will vary. Okay, but if you are using very small model like 2700, 2600, then it will be like 6 ports or 4 ports only, like that. Okay, so apart from that, we'll be having another set of ports. Okay, we'll call them as fiber channel adapters. Okay, we'll call them as fiber channel adapters, FC, FCA, sorry. Okay, fiber channel adapters. Why? What is the purpose of the fiber channel adapters? For SAN connectivity. So, with the help of these fiber channel adapters only, our controller will be connected to the SAN network, storage area network, and will serve the storage to the clients. Our clients will be able to access the storage on top of this controller through these ports. Again, the number of ports depends on the controller. Apart from that, we'll be having a few more ports. Those are, we'll call them as SAS ports. Okay, SAS ports. SAS ports. So, what is the purpose of these SAS ports? I told you, right? In the back end of our storage, disk shells will be connected to the controllers. Disk shells will be connected, right? How come disk shells will be connected to the controller? Via SAS ports only. With the help of SAS ports only, the disk shells will be connected to the controller. Disk shells and disks will be connected to the controller. Okay. Disk shells and disks will be connected to the controller. Okay. Next. Yeah, apart from all these ports, we'll be having either 2 ports or 4 ports. These are cluster interconnect ports. Okay, few models will be having only 2 ports, few models will be having 4 ports. I have already shown you, right? The number of ports again depends on controller model. So these are cluster interconnect ports. You know the purpose of the cluster interconnect ports, right? In order to connect all the controllers within the cluster, in order to enable the communication between the nodes in cluster. So with the help of these ports only, the controllers within our cluster will be able to communicate with each other. Okay. Cluster ports. Okay. Cluster ports. So with the help of these ports only, this controller will be connected to the other controllers within the cluster, and they'll be able to share the configurations and all with each other. I told you, right? These are pre-configured ports. Whenever you do the connections, whenever you connect them to the switches or the other controller, they'll get a IP address 169.254. Switchless cluster, switched cluster. Yeah, those ports only. These. So that's it. These are the number of ports available on top of our controller. Okay. Any questions, guys? Any questions so far? Just respond. Like if you don't have any questions, then I'll proceed
No,
further.
Navin. Yeah,
No, no.
for me.
Cool. Thank you. Thank you so much. Now let's talk about the components inside our controller. Now let's talk about the components inside our controller and what are their functionality. Okay, so generally in our controller we'll be having two components, two main components. Okay, two major components. So one is memory or cache. We'll call it as either memory or cache. You can call it with any name, or cache. Okay, and another component is called NVRAM. NVRAM. The full form is non-volatile random access memory. Okay, NVRAM. So basically, this memory or cache will be logically divided into two parts. Okay, this memory or cache will be logically divided into two parts. One is a write part. Okay, another one is read part. Okay, one is a write part, another one is a read part. And when it comes to NVRAM, okay, again NVRAM also will be divided into multiple parts logically, but the number of parts depends on your controller. Okay, like for example, if your controller is a standalone controller, okay, if your controller is a standalone controller, then it will be divided into only two parts. Okay, only two parts. For example, if your controller is not a standalone controller, it is a part of a HFA. That means there will be another controller connected to your this controller. Okay, there is another controller. Okay, connected to this controller, and these two are part of HFA. Then your controller will be divided into logically. This is not physically, logically. Okay, your controller will be logically divided into four parts. Okay, if it is part of HFL. So nowadays everything is part of HFL, right? Nobody is buying standalone controllers. So mostly NVRAM will be having four partitions only, unless if it is a standalone. Okay. So first two parts of the NVRAM, okay, first two parts of the NVRAM belongs to local controller. Let's assume that my controller, this controller name is Fast01. I'm assuming that. Okay, and this controller name is, the partner controller name is Fast02. For my convenience, I'm assuming that my controller names, okay, Fast01 and Fast02, so that I can explain you clearly. So first two parts of the controller in the NVRAM belongs to the local controller, which is Fast01. Okay, whatever the second two parts are there, right? Second two parts of the NVRAM, they belongs to the partner controller. Okay, they belongs to the partner controller. Partner controller means Fast02. Okay, Fast02. The same way here also our NVRAM part in partner controller also our NVRAM will be divided into four parts. Even partner controller will be having the same components, right? Same ports, same components, everything will be there. Okay, memory also will be divided into two parts, read and write, like that. Here also the first two parts belongs to the local controller. Local controller means nothing but our Fast02 here. Okay, the remaining two parts will be, they belong to the partner controller. For Fast02, who is the partner controller? Fast01, right? So yeah, that this belongs to Fast01. Okay, this is how it is. Now let me save it again. So yeah, okay, okay. Now what is the functionality? What is the functionality of memory and NVRAM? How they'll contribute? What is the key role of them in controller? Okay, So generally, this memory, NVRAM, they will play a very crucial role in data processing. Data processing means nothing but normally we'll present a logical partition from our storage to the clients, right? So when they're accessing the data inside it, or when they're copying the data to the logical partition presented from storage, everything will go through controller only. Without controller, it will not go to direct disk shelves, right? Everything has to go to the disk shelves via the controller. So within the controller, these components will play a very crucial role. Okay. So first, what we'll do, we'll talk about writes. We'll talk about write, WRITE, write request. For example, I have presented a logical partition from my pool. Let's assume that I have one disk shelf, and with that one disk shelf, I have created a logical partition here, and I presented this logical partition to my client. Okay, and he is accessing it, and after accessing it, he is writing something. Okay, he is writing some video files, or some text files, or some Word documents. He is writing some data. So when he is writing the data, if he is connected to the NAS, okay, then the data will enter into the controller through NAS ports, network interface cards. If he is connected to our controller via SAN, if we presented the storage to him via SAN protocols, then it will enter into the controller via fiber channel adapter. Okay, when it into the controller, it will not write the data directly to the disk shelves. Okay, because in the end, even though if you are creating a pool and logical partitions and all, in the end it has to be stored in the disks only, right? Disk shelf and disks only, right? But it will not go to the disks directly. Okay, so initially, whatever the data written by client, it will copy it to the right part of the cache. Okay, it will copy it to the right part of the cache. Okay, the same data journal, the same data journal will be copied to the one of the local NVRAM parts, one of the local NVRAM parts. And again, the same data will be written to the partner controller NVRAM reserve. In fast 0 also, we have a reserve for fast 01, right, in the NVRAM. So it will write the data to there as well. Okay, so the same data, okay, it is copying in three places. This is the original data, and these two are the journal copies of the data. Okay, just I don't know how to express it. Just Google it, journal. Okay, you'll get it. Like you'll be able to understand. It is a kind of in detail information of the data or something like that. Okay, so the data is writing in three places. Whatever the data coming to the our storage, the data will be written to right part of the memory or cache, and local NVRAM reserve, and partner controller NVRAM reserve. Okay, so like that it will keep on writing the data here. So how long it will write the data? It will maintain the data in memory and NVRAM only. It will, okay, there is a process called CP shortcut, that is a short form. The full form is consistency point. Okay, that is the full form of CP. This is a continuous process which will run in the background for every 10 seconds. For every 10 seconds, there is a process called consistency point which will run in the background every 10 seconds. So whatever the data you wrote, okay, that is written to the controller storage for last 10 seconds, that will be stored in the memory and local controller environment and partner controller environment. So once when it reaches the 10 seconds mark, what it will do, it will trigger this process. So once it is triggered this process, my memory or cache will work with this part of the NVRAM, and what it will do, whatever the data that entered into controller in past 10 seconds, that will commit those data into the disks. Whatever the data came into our controller for past 10 seconds, that data will be committed to the disks. Okay, that data will be committed to the disks. Okay, that is fine. But how about the incoming request? See, it is not like our clients wait till it commits the data to the disks, right? My clients will keep on writing the data. So during that time, what it will do, my memory can do multitasking. My memory can do multitasking. My memory will work with the first part of the NVRAM, and it will commit the data, whatever came in last 10 seconds. And again, the the same memory will work with the second part of the NVRAM and will take the request from the client. So whatever the data coming into our controller, again the data will be saved into other free space of the memory, okay, and other part of the NVRAM, other part of the NVRAM. So this will continuously happen till again next 10 seconds. Once 10 seconds period completed, again it will trigger a CP. Okay, again it will trigger a CP after 10 seconds. Okay, so meanwhile, my memory is already working with the first part of the NVRAM to commit the data to the disks, right? Once they are committed, what they'll do, memory and NVRAM flush the data in them. Once they committed the data to the disks, what they'll do, they'll wipe out the data within them, and they'll get ready for next consistency point. Whenever that consistency point triggered, this time what it will do, my memory will work with the second part of the NVRAM, and it will commit the data to the disks. When it is committing the data to the disks, the first part of the NVRAM and my memory, what they'll do, they'll again take the data from the clients. Like that, these two parts of the NVRAM, they'll keep on exchanging their roles. When first part is taking the data from the clients, my second part will commit the data to the disks. When my second part is taking the data from the clients, my first part will commit the data to the disks, and memory will be involved in both the tasks. Memory can do committing the data as well as taking the data from clients. It can do multitasking at a time. Okay, but when it comes to NVRAM, we have two parts, right? One part will do committing data to the disk. Other part will taking the data from the client. Like that, they'll exchange the role whenever the consistency point trigger. They'll keep on doing that. Okay, this is how it will work. Any questions, guys, so far, or do you want me to repeat it one more time?
Yeah, like from the consistency port, can you repeat one more time? Like up
Sure.
to yeah, up to NVRAM and everything is fine.
Hmm.
From the down,
So
you
that's fine.
you you
Yeah.
convert it right, like SAS, and from there,
Okay.
SAS is also good for me.
Okay. Yeah. So see, so whatever the data that are written to your logical partition will be not written directly. So for example, if I copied some data, it will be not immediately go to the disk. It will not immediately go to the uh, copy to the disks. Okay. Whatever the data you written, that will be initially saved in the memory and NVRAM only. Okay. Initially, it will be saved in the memory and local controller NVRAM and partner controller NVRAM. So how long it will be saved in the just memory and NVRAM? Till 10 seconds. Once the 10 seconds period is completed, so there is a background process which will happen automatically, and this background process called consistency point. Okay, the name of the background process is consistency point. This will be triggered by data on tap. Data on tap will trigger this process, will will trigger this background process. Once this 10 seconds period it is completed, when on tap triggered this consistency point, So whatever the data that came in the past 10 seconds, okay, that will be committed to the disks. Now the data, who owns the data? First part of the NVRAM, right? Initially, and memory. So what they'll do, they'll work together, and whatever data that written in past 10 seconds, they will commit the data to the disks in the background via SAS ports and all. Okay. During this time, my client will not wait for me to will not wait for controller to finish that commitment process, right? He'll keep on pushing the data, right? See, whatever the servers and all, they'll keep on pumping the data to the storages, right? They'll not wait for the storage to commit the data to the disk. So during this time, what my second part of NVRAM will do, my second part of NVRAM will work with the memory and will take the data from the clients for next 10 seconds. During this time, my first part and the memory, they are committing the data to the disks. Okay. Now, again, another consistency point triggered by on tap after 10 seconds. So once the consistency point is triggered, this will, whatever the data written to the second part of the NVRAM and memory, they'll work together and they'll commit that data to the disks. And during the earlier consistency point, already NVRAM and memory written the data, committed the data to the disks, right? Once they committed data, what they'll do, they'll wipe the data within them, and they'll get themselves empty and will ready to take the data from the clients. Okay, like that. After that, again, another consistency point triggered. That time, whatever the data written to the first part of the environment memory, they'll work together and they'll commit the data. During that time, the second part will take the data from clients. Like, they'll keep on exchanging the roles. One part is committing the data to this, the other part will take the data from the clients. In the next consistency point, whatever the data written till past 10 seconds, that will commit the data to the disk, and the other part will take the data from clients. Okay, this is how it will work. They'll keep on exchanging the roles. When the memory can do multitasking, memory can work with both the partitions of NVRAM, and it can do multitasking. It can commit the data to the disk, and it can take the data from the clients at a time. It can do multitasking, whereas NVRAM can't do that. NVRAM, one part is will commit the data to the disk, and the other part will take the data from the clients. The consistency point is nothing but it is a kind process which will happen in the background. Even not only here, everywhere it is the same. Even when you copy something to your laptop, okay, for example, you copied a 1 GB audio file or video file, it will not copy the data directly to the disk. What it will do, it will split that video or whatever file you are copying into small partitions, and first the data will be copied to the temporary memory of your laptop, and from there periodically it will commit the temporary data from temporary memory to your permanent memory. Permanent memory means nothing but your hard disk. So here, temporary memory means nothing but our cache and NVRAM. These are the temporary memories. Okay, and permanent memory means nothing but our disk shelves and disks, and the disks in the disk shelf. Okay. Is it clear, Krishna?
Yeah, yes, Navin. Yeah, I got.
Okay. Zubair, Beulah, Amar, any questions so far?
Yes, the thing is actually with respect to phase one, this is okay, and with respect to phase two, this happens in the at the
Exactly. Yeah, good question actually. So you can ask me like, okay, this makes sense. One part is working with memory and committing the disk, and the other part is taking the data from clients and all. Why we require this partition? Why we require uh, FAT01 reserve one FAT02, and the same way FAT02 reserve one FAT01? See, the same kind of process will happen on the other controller as well. So whatever the data come into this controller, that will be written to this controller memory and this controller NVRAM, and the same way it will store here as well. Okay, then why we are storing the same data in partner controller? That is for protection purpose. For example, okay, my NVRAM and memory, they are working with clients and they are taking the data from my clients. Okay, for example, let's assume that my second partition is taking the data from clients. Okay, now before consistency point triggered, okay, my controller went down due to some hardware issue or due to some power issue or something. Okay, so whatever the data that copied in past 8 seconds, that is just copied to the memory uh, and NVRAM only, right? That is not yet committed to the disks. And as I told you, this is a temporary memory, right? This is a temporary memory, not a permanent memory. So whenever the controller goes down, whatever the data you have on temporary memory, you will lose it, right?
Yes.
Is it correct? Clear? You will lose it. So in order to avoid that data discrepancy, we are copying another copy of the same data to partner controller, so that the same data will be there in the partner controller. So my FAT01 went down without committing the data to the disks due to some issue. Still, the same data, the uncommitted, is available to us in partner controller. And I told you, right, when I'm discussing about a HA pair and all, whenever one controller went down, the partner controller will help and will work, both controllers work, right? So, so as it has the latest data, uncommitted data, my second controller will take the responsibility of controller one as well, which is a FAT01 as well, and will commit the data to the disks, and it will keep on working work until my FAT01 come to service again. The reason why we are copying the data to partner controller as well. Is it clear, sir? Is that
Yes.
what you asked me?
Yes. Yes. Yes.
Yeah, yeah. So why we are maintaining same, yeah, same FAT01 reserve on FAT02? That is for protection. If my controller went down unexpectedly, if there are some uncommitted data in my environment memory, we if we don't have a protection, then we lose the data. That is the reason, in order to maintain data consistency, okay, in order to avoid that danger, we are maintaining the same copy of the data in partner controller. So if my controller went down due to some unexpected issue, still I don't need to worry about the uncommitted data, because I have the same data in my partner controller as well. And from there, that will take care of committing the data and dealing with the clients. Okay. Yeah. Any questions? Amar, you're not talking. Okay. Fine. Okay. Same thing with the second controller as well. Like whatever the incoming request for the controller one, I mean, sorry, FAT02, those will be saved in memory and local part of the NVRAM, and the same way they'll be saved here as well. For example, if any thing wrong went wrong with my controller 2, that's fine. I have the same amount of I mean, I have the same uncommitted data in my controller one, right? So my controller one will take care of the data and will commit the data to the disk and will be able to handle everything. Okay.
One thing
Hmm.
regarding this latency time, will this is this fixed actually, or we can change it according to the?
Uh, what do you, latency?
I mean to
I
say the
did.
consistency point. Yeah, the
No,
trigger.
this is a fixed. This is a fixed thing. Good
Oh,
question. This is a fixed actually. This is a factory default setting from NetApp. But there are some factors which will trigger the consistency point before 10 seconds as well. But I don't want to discuss those factors right now. I just want to discuss about those factors in advanced session. For now, let's assume that consistency point means 10 seconds only. But there are some factors which will trigger earlier consistency point earlier than, I mean, less than 10 seconds also. Like even if it is 5 seconds also, There are some factors which will trigger the consistency point, but let's talk about them little maybe in advanced classes. Okay, good question, sir. No one asked me. No. Yeah. Okay. So if you are good, then let's proceed with the other thing. This is how it will. I mean, whatever the write request come into the controller will be committed to the disks. Now let's talk about the read request. Okay, writing means I'm writing some new data, new documents, new video files or audio files to the storage. What if I'm reading something? That means already data is there. Now I'm reading that. That means I have copied a movie. Now I want to play that movie. That is called read request. Or I have a document copied. Now I want to read the document. That is read request. Okay. So again, if it is my client is connected to storage via NAS, then it will the read request also will enter into controller through NIC ports. And if it is connected to via SAN, then the request will enter into our controller via fiber channel adapters. So so with respect to read requests, okay, we our right part of the memory don't deal with the read request. And the same way, my NVRAM also, it will deal only with the write request. It will not deal with read requests. Okay. So now whenever any read request comes, okay, it will not go to the disks directly. First, what it will do, it will come to the read part of the cache or read part of the memory. Okay. So what my read part of the cache will do, my read part of the cache will store the frequently accessed data. Okay, will store the frequently accessed data. For example, my client is watching a movie very frequently. So what it will do, it will get that movie file copy from here to here, and it will save the data here only. So that whenever he is trying to play the copy again, first it will come to the read part of the cache, right? So okay, the movie stored here, so it will play it from here only. Okay, we'll call it as read hit. Read hit. That means whatever the client requesting data, if that is found in read part of the cache, it will improve the performance. So we'll call it as a read hit. For example, okay, let's assume that the data which client is requesting, if it is not found in the read part of the cache, then what it has to do, it has to go through the backend SAS ports, and it has to enter into the disk shelves, and it has to scan all the disks and the disk shelves. Let's assume that it has multiple disk shelves. Yeah, what it has to do, it has to scan for the data on all the disk shelves and all the disks, and it has to find the data and bring the data, copy the data in the read part of the cache, and serve it to the customer. So it will add additional latency, right? If there is a read miss, it has to go through the entire process in the backend, which will add additional latency to your read request. So which will degrade the performance. Okay. So if you get high number of read hits, then your performance will be very high. Your controller performance will be very high. If you get high number of read misses, then your controller performance will be degraded because it has to go through the background process, right? So which will add additional latency and which will show a performance impact. Okay. So what is the purpose of the read cache, read part of the cache? It will store the frequently accessed data on read cache so that it will serve quickly and a better way to clients. For example, my client is not playing that movie anymore. Like it waited like for 1 week or 10 days. In last 10 days or 15 days, my client not played that movie. Then what read cache will do? Read part of the cache will do. It will flush this data from the cache itself. The data will be there in the disks permanently. No one can delete it unless client. But in cache, it will remove it. because this cache has some limitation, right? It will be like maybe 16 GB or 20 GB or 32 GB based on the controller model. The cache size will be decided. Okay, I mean the cache size will be okay. So it cannot store all the data which is in the disk shelves, right? Only it will store the frequently accessed data. If my client is not accessing this file frequently nowadays, what it will do? It will flush the data from the cache. Okay, but the data will be there again. After some time my client access trying to play that movie, it has to go to the backend and it has to get that file and it has to copy here. Okay, that is how read request will work. Any questions? Even in our laptop also we'll be having cache like 4 MB or 8 MB cache based on your laptop configurations. And for example, if you open a browser and if you are using Facebook very frequently, if you type f, then it will autofill the remaining data, right? acebook.com. How it is doing that? Because whatever the things you are accessing, okay, that will be cached by your browser. The browser data will be saved in the your laptop cache, so that you don't need to type acebook.com. It will save your time, right? At least 1 second. The same way. Okay, any questions?
No, sir.
Cool, thank you. Now let's talk about the remaining things. We have another part called flash cache, or we can call it as again PAM2. Okay, PAM means the full form is performance acceleration module. Earlier generation we have a PAM. Now they introduced a new generation of PAM called PAM2. That's it. Nothing else. Okay, which is an improved version of the flash cache. Again, we can call it as either PAM or flash cache. It has two names. Okay, so what this flash cache will do? What is the main functionality of this flash cache? So this flash cache is responsible for improving the read performance, improving the read request performance. So I told you, right? Whenever there is a read request entered into our controller, first it will go through the read cache. If the data, sorry, if the data is not available, then it has to go through the disk shelves directly. But if you have a PAM, then it will not go to the disks directly. If there is, if you don't find the data in the read cache, it will go to the second place called this PAM or flash cache. Why? What is the functionality of flash cache? What it will store? What it contains? I told you, right? Whenever memory and NVRAM committed the data to the disks, okay, after committing, they'll flush the data, right? That is what I told you, right? During the write request. Okay, when they are flushing the data, what NVRAM will do? NVRAM will store a log file. A log file means where it has stored the data, like in which disk shelf, in which disk, like that. It will maintain that log file information. So when it is um, wiping the data, it will dump those logs into, okay, it will dump those logs into this PAM or flash cache. Okay, and along with that, and I told you another thing, when there is a, I mean when there is a data my client is not accessing frequently, that will be wiped out from the read part of the cache, right? So whatever the data that wiped from the read part of the cache, the data will be stored in this PAM. Okay, the data will be stored in this PAM. Okay, so whenever there is a read request came in to read part of the cache. If it was not able to find the data here, then the request will go to the PAM. First, what PAM will do? PAM will search for the data which is frequently flushed by the or wiped out by the read part of the cache. If it finds here, it will copy the data from PAM to read part of the cache, and it will serve the data to the clients. For example, if it was not a if that the data was not found in the here, then what it will do? It will go through the logs, and by seeing the logs, it can find the data, right? Find the data exact location, so that it don't need to scan all the disk shelves and the disks. It can directly go to that particular location, and it can bring the data to the read part of the cache, and it can serve the data. Like, it is a kind of maintaining indexes. Like, if you have a book with thousands of pages, if I asked you to open a particular topic, if that book don't have any index, then what you need to do? You have to go through each and every page, right? But if that book has 10 pages of index, you don't need to go through all the pages, right? You can just go through the 10 pages of index, which will save hell lot of time for you, right? By seeing the index page, okay, this particular topic in this page, so you can open that particular page, you can go through the topic, right? The same way here, the data was not found in the PAM, will go through the logs, NVRAM logs here, which are stored in the PAM, and find out the exact location of the data, and it will go there directly. So that is how it will improve the read performance of your controller. Any questions? In earlier models, this PAM is a optional component actually. That means either you can have a PAM or you can have a controller without PAM also. But if you want PAM, you need to pay some extra money, something like that. Whatever the new models, I mean, like from third generation onwards, they made it as a mandatory part, because it will show a very huge impact on the read performance. That's why they made it as a mandatory part. Okay. Any questions, guys, on PAM?
Yeah, no, Naveen. Yeah.
Amar, you are not talking, man. Are you able to understand?
Yes, sir.
Okay, cool. Just ask me if you have any questions. Okay.
Okay.
Okay. Thank you. Now let's talk about the fourth and final part. But this is not. This is a very important one, which we'll call it as flash module or boot device. Okay, boot device. So what is the purpose of this? So we are talking about the operating system, right? Every controller will be loaded with a data on tap, or from 9 onwards it is on tap. Yeah, on tap operating system. So the operating system will be stored in this flash module or boot device. The same thing in our laptop also, operating system will be stored, right? Where our operating system will be stored? In our laptop, it will be stored in BIOS. Okay, actually, it will be not stored in the C drive. Okay, earlier I used to ask this question to people. Most of them, like only one person answered me correctly. In our laptop, operating system will be stored in the BIOS section. BIOS. There is a chip in the, yeah, on top of your motherboard. Like it looks like a battery in the watch, wristwatch. Okay, that will be stored in that particular place. Whatever the things you have in C drive, those are just supporting files, installation files of operating system. So when you hit the power button on your laptop, first the power will hit the BIOS, and from there it will load the operating system to the C drive, and it will start booting up. The same thing here. Whenever you hit the power button on the controller, first it will trigger the flash module or boot device, this thing, and it will load the on tap to your entire controller, and your controller will be booted up. Okay, so this is a place where your on tap operating system will be stored on. Again, this boot module also, again, it will be divided into two partitions logically. One is a current partition, Another one is a previous or old partition. Okay. So for example, let's assume that right now in current partition, I have on top 9.1. Okay, in older partition, let's assume that I have on top 9.0 something, 9.0 P12. Let's assume that is some version. Okay, now right now I'm running on 9.1. I'm planning to upgrade my ONTAP to 9.3 or 9.4 or 9.2, whatever it is, 9.3. Let's assume that. So whenever I'm installing that new version of ONTAP, what it will do, it will not disturb the current partition, because that is the partition it is using for um, work, right? So what it will do, it will not disturb the current partition. It will override the old partition, previous one. See, this it will remove this 9.0 P12 from the previous partition of the flash module or boot device, and it will write the uh, data here, like a new version here, like for example 9.3 P16 I'm installing now. Let's assume that patch 16. Okay, it will install everything here, and we need to reboot the controller now. I mean, the controller will be rebooted. When it is rebooted, now my controller itself will look into the flash module, and it will be able to discover the latest version. Now it is discovered 9.3 P16, which is the latest version of ONTAP. So what it will do, it will mark this 9.1 as previous partition. Okay, previous partition. Sorry, it went there. Okay, previous partition, and it will mark this as current partition, and your controller will be booted up with this 9.3 P16 on tap. Okay, why? One is the downtime. It will make your downtime minimal. That means if you are disturbing the current one, for example, let's assume that if it has only one partition, then it will maintain only one operating system version, right? So whenever you're installing, obviously even during the installation time as well, you require a downtime if it has only one partition. But as this has two partitions, now it is running with 9.1, so it is still functioning, doing its daily work, even when it is installing the ONTAP on the previous partition. Only during the reboot, just it requires a downtime. I mean, not downtime exactly. Yeah, your controller will go down, right? So it will minimize your downtime. That is the one thing. Another thing is, for example, I don't like 9.3 P16. Like I found lot of issues in 9.3 P16. I want to go back to my previous version again. No problem. What you can do, you can again boot back to your older ONTAP, which is 9.1. Okay, that is the reason your flash module or boot device will maintain two versions of data ONTAP every time. Okay, whenever you want to upgrade again, like for example 9.4 or 9.5, again it will not disturb the partition which contains 9.3. I mean, the current partition, it will override the previous partition, and after reboot it will boot up with the latest version. Okay, that is how it will work. Any questions, guys? Hello.
Yeah, Naveen. Yeah, good, good.
Okay, if you are good, then yeah, let's stop the session for today. We'll Yeah, we'll discuss a new topic tomorrow. Yeah, this is a very important one actually. When it comes to interview, if they want to ask you a very in-depth, uh, and like if they want to take a tough interview, the people will go through basic stuff only, because lot of the people who are working on NetApp also don't know how controller functions. Trust me. If you ask,
Yeah.
like, if you know any person who is working on NetApp, ask him, like, what is the CP, how it will work, how NVRAM will work, and all. He'll be not able to answer those questions. Okay. So I'm just posting this image as well here. Mm, this is Windows 11. It will not work. Okay, I'll upload the images also to the same place where we are uploading the videos.
Sure. So Naveen, like,
Okay.
do you have any kind of document for this architecture?
Yeah, yeah,
Yeah.
yeah. I'm going to provide the materials. I'm just waiting for the first
Not
fees.
yeah, not an issue, Naveen. Yeah, because I am noting down all the points, whatever you are saying. Like,
Hmm.
I will go through once the session is